Hi class, Dr. Searcy here with the Chapter 2 lecture on the Chapter 2 odds problems. Remember that this chapter is called frequency distributions, and I'll just go over each question, beginning with number 1. So the question is saying, place the following set of n equals 20 scores in a frequency distribution table. Okay, so just remember, you've got several different scores here, right? You've gone out, you asked some people some questions, and you've got 20 different answers from 20 different people. Now, you're going to put them in the frequency distribution table so that you can organize them and summarize them. And remember, the table basically looks like this, right? So you've created your X column, and the X column is just simply where you are writing the category of answers that you got. Here I've got a 7, and that's saying, and here someone gave me an answer of a 7. I've got a 6, again, someone gave me an answer of a 6. And so on and so forth, all the way to the number 1. Then remember that your F column is your frequency column. That's the column where you're saying how many of each score that you got. So here we're saying for a score of 7, there were 2 people who reported a 7. I'm going to see if I can find those 2 7s in the data. Oh, I see one here and I see one there. Right, so those are my 2 7s. And notice I don't see any other 7s anywhere else in the data. Okay, so that's our answer for question number 1. Let's go ahead and move on to question number 3. Here the question is, for each value requested, or find each value requested for the distribution of scores in the following table. Let's see, where, here's the table. Okay, so again, you've got your X column of data, and you have got your F column showing the frequency of how often each item occurred. Okay, so first thing that you need to figure out is lowercase n. Remember, lowercase n is how many participants did you have in the study. Just like up here, you had n of 20 because you had 20 people that gave you an answer. When you're trying to get n from the table, remember what you have to do is you have to count up the numbers, or you have to add up the numbers in your F column, in your frequency column. And so I have already done that. I've gotten a total of 15. That says that we had 1 plus 3 is 4, plus 4 is 8, plus 5 is, let me do that again. 4 plus 4 is 8, plus 5 is 13, plus 2 is 15, right? So I can write my answer as n equals 15. Okay, so now remember, the next thing that's being asked for is the sum of x. Now remember, this is your X column, and so what you ought to be able to do is just add up all the numbers in your X column, and that should give you the sum of x. But you cannot do that. And remember that the reason why you cannot do that is because when you're adding up your sum of x, you're adding up for your x values each time you had an x value that was that number. Okay, so we're saying I'm going to add up 1 5, but I'm also going to add up 3 4s and 4 3s and 5 2s and 2 1s. So remember that the way that we have to do that is we have to create a couple of new columns, or at least one new column, where we're saying the one new column that we're going to create is a column for x times f. And so when we do that, we say, okay, my first row is 5 times 1 gives us 5, 4 times 3 is 12, 3 times 4 is 12, 2 times 5 is 10, and 1 times 2 is 2. Once I have each one of those individual row values, then I can go ahead and add up the column, and the sum that I get for the column will be my sum of x, or the sum of x equals 41. But then there's another way that you need to be aware of doing your addition, and that is adding up or summing up x squared values. So remember, the way that you're going to do this is you're first going to create a column called x squared. And each individual value in there is going to be each x value squared, right? So 5 times 5 is 25, 4 times 4 is 16, 3 times 3 is 9, 2 times 2 is 4, 1 times 1 is 1. From there, remember that now when you go to sum them up, you're going to sum up the frequency of each occurrence of this x squared value. And the way that you're going to do that is similar to what you've done here. You're going to create a new column called x squared times my f. So it's 25 times 1 gives me 25, 16 times 3 gives me 48, 9 times 4 gives me 36, 4 times 5 gives me 20, 1 times 2 gives me 2. So now that I've created this column, I can go ahead and add up the individual amounts inside the column and sum it up, and I get 131. So there's my sum of x, and there is my sum of x squared. Let's go ahead and move on to problem number 5. Let's see what we got here. So it says, for the following scores, the smallest value is x equals 13, and the largest value is x equals 52. Right, so there's our 13 there, and there's our 52 there. This is our smallest score inside the data. This is our largest score inside the data. Place the scores in a grouped frequency distribution table. And so it actually looks like we're going to create two different ones. We're going to create a frequency distribution table, a grouped table for A and a grouped table for B. They're just saying that when you create your table, use an interval width of 5 points for question A. So when we do that, right, we're creating this interval width of 5 points. That's what your interval width is going to look like. It's each interval is 5 points wide, from 50 to 54, from 45 to 49. Once you've created each group or each interval, you're then going to look inside the data and you're going to count, okay, what's the frequency of each interval? How many times did I get a number that was inside this interval? Or how many times did I get a number that was inside this interval? And the way that you're going to represent that is with your F column, right? So here in your F column, this 2 is saying that there were 2 occurrences where I found a number in here between 50 and 54. I'm going to see if I can find those two. Something between 50 and 54. Ah, here's a 51. Where's my second number? Another number. Oh, and there's 52. Ah, 52's must be a lucky number because it appeared twice in this list. Okay, but that's my grouped frequency distribution table for problem A, where they asked us to create the interval being 5 points big. Now, for question B, they're asking us to create the interval so that it is 10 points big. And that's what this is going to look like, right? So now my interval is 10 points big. Say, for instance, that first one is 50 to 59, next one is 40 to 49, and so on. So now I'm going to ask the same question with my F column. How often did I get a number between 50 and 59? Here I'm saying that it happened twice. Oh, so yeah, it was still that 52 and that 51. I was thinking that maybe I had other numbers now too, but no, it's just that still that 52 and the 51. But there's the interval. I'm sorry, the grouped frequency distribution table with my intervals of 10 points big. Now we can go ahead and move on to our next problem, problem number 7. 7 reads, for each of the following samples, determine the interval width that is most appropriate for a grouped frequency distribution and identify the approximate number of intervals needed to cover the range of scores. So just to make sure that you understand this question, again, they're asking us to create a frequency distribution, how we would create a grouped frequency distribution table. Here, they're not asking us to actually create the tables. Instead, they want to know how our intervals would look. Okay, so here they're saying, like for question A, you got sample scores that range from 8 to 41, right? So that's the range of your X values. What they're asking basically is how many intervals would you create and how big would each interval be if this was your range? Well, we can answer that question. Oops. Okay, so we can answer that question. Did I just throw this off? Okay, it's back. Okay. What I would do to figure out how big my intervals are is I first would think about that range of 41 to 8. And I want to think about how many numbers are there between 8 and 41. To answer that question, what I could do is a simple subtraction problem. 41 minus 8 is 33. So that means that there's 33 spaces in between the 41 and the 8. So that means that when I create this grouped frequency distribution, I should be thinking in terms of trying to organize for 33 spots. One way that I can do that is I can ask myself, what two numbers can I multiply to each other that would give me a number close to 33? Right? So there's like, and I'd have to do it to where the number is above the 33, not below, right? Because I want to capture everything within the 33. It's okay if I go over, I just don't want to go below. So a nice number that I can get by multiplying two numbers is 35, right? And I can get that by multiplying 5 by 7. So the way I could organize it is I can say, okay, to accommodate the 33 spaces, I'm going to create intervals that are 5 points wide and where there are 7 intervals, right? And that way I should have enough space within my intervals to account for all 33 spaces. Let's look at the next problem. Problem B. Here we're saying that we got this range from 16 to 33. Again, the first thing that we're going to do is find out how many numbers are in between 16 and 33. The way that we're going to do that is by subtraction. So we're seeing, okay, there's 17 numbers between those two values. So again, I'm going to think of two numbers I can multiply by each other that would give me something close to 17. Those two numbers that we came up with were 2 and 9, right? Because 2 times 9 gives me 18. 18 is above 17, so I can capture all the numbers. Let's go ahead and move on to problem number C. Here we're saying same question. First thing I want to do is find out what's the difference between 98 and 26. We do that by subtraction, and we see it's 72. So now again, I want to think of two numbers that I can multiply by each other that would get me near 72. So it turns out I can think of 10 times 8, right? So I'm going to create a group frequency distribution table where each interval is 10 points wide, and that'll give me 8 intervals. But within that, I should be able to cover all 72 spots between 98 and 26. Okay, just in case you're not quite sure how all this worked on this question, let me just kind of note that you're really not going to see this kind of question in future chapters, so I wouldn't worry about it too much. And so I'm just going to kind of breeze past it. Now, though, Next, question number 9 is asking, describe the difference in appearance between a bar graph and histogram, right? So remember we talked about a bar graph in lecture and a histogram. We said those are two different kinds of graphs that we can use to present data. The question that we have here is to describe the circumstances in which each type of graph is used. So we got two things that we have to answer. What's the difference in appearance between the two, and what circumstances would we use each type of graph? So let's just go ahead and answer this question all together. I'd say that with regard to the first question about the appearance, the main point that we want to make about appearance is that for the histogram, the bars touch, right? They're touching each other. For the bar graph, the bars don't touch. Right, so that's the main difference in appearance between the histogram and the bar graph. Remember that in this class, the graph that we're going to use most often is the histogram. So most often we're going to use graphs where the bars are touching. Now the other question that we have to answer is about the circumstances. What circumstance would you use each type of graph? To answer that, go back to lecture. Remember that we said that for the histogram, you're going to use it with either interval or a ratio scale. And for the bar graph, you're going to use either a nominal or an ordinal scale. Okay, moving on to the next question, number 11. Here they're saying, a survey given to a sample of college students contained questions about the following variables. For each variable, identify the kind of graph that should be used to display the distribution of scores. A histogram, a polygon, or a bar graph. Okay, first thing that you might be noticing here is the word polygon. And you might be starting to panic because Dr. Searcy never said anything about a polygon. So I'll just really quickly explain what a polygon is. A polygon is similar to a histogram. And I think I've got an example here. Right, okay, so just really quickly to explain what a polygon is. Here you've got a set of data, right? A table showing X values and their frequencies. We created a polygon to illustrate what's going on here so that we could organize and summarize it, make the stuff more understandable. The polygon is set up exactly the way that we talked about setting up a histogram, where you've got your X values here on the X-axis, and on the Y-axis, you've got the frequency of the X values. And like the histogram, the dot on top of each X value is representing the frequency, right? So take this 1, for instance. This 1 corresponds to the 1 in the X column. The dot corresponds to the frequency in the F column. It's a 1. And so it's saying there was 1 occurrence of the score of 1. Same thing with 2. It's saying that for the X score of 2, there were 2 occurrences. So the dot is saying that's where we're at on the Y-axis. The reason why I say this is like similar to the histogram is basically each dot is like the top of the bar in the histogram, right? So remember the histogram is a bunch of different bars. And so that's what is happening here with the polygon, the bars. I would say that the reason why you might want to use a polygon instead of histogram is if you want to see what the relationship is of the frequencies as you move from one X value to the next. Exactly what direction do the numbers go in? And this helps you to see if there's like a trend that's happening that maybe the bars don't quite reveal as well. Okay, so that's my quick explanation of what a polygon is. Let's get back to the question that's being asked. Basically what they're saying is they've got these 4 examples here of different kinds of studies that have been done. You want to show the data using either a histogram, a polygon, or a bar graph. Question is, which is the appropriate way to show the data? Okay, so for question A, we're saying that the data that you've gotten is the number of brothers and sisters, right? So you've gone out to participants and you've asked them, how many brothers and sisters do you have? In determining whether you should use a histogram, a bar graph, or a polygon, you want to remember, well, what kind of data do we have here? Do I have interval ratio, nominal, or ordinal? Here, I'm thinking of this as like labels no, actually I'm thinking of this as ratio scales, right? Because it's a ratio because someone could have no brothers or no sisters. So because this looks like ratio, I'm thinking that you want to create a histogram with it. And yes, we were right. By the way, I'll also notice that wherever you can use a histogram to show your data, you also can use a polygon to show your data because of how the two are similar to each other. When would you want to use a histogram or a polygon? When you have ratio data. Okay, so next question is about birth order, and the thing that you're going for here is birth order position among siblings. Birth order position. Here I'm hearing like a first, second, or third. Remember, first, second, or third is referring to that ordinal scale. So I'm thinking, yes, because we're talking ordinal, we want to use a bar graph. So then for question C, we've got gender. Gender, male or female. That is sounding nominal to me because it's just like labels or names. Let's see if I'm right. Yes, I'm right. Okay, because this is a title, you're either male or you're female, because that's a name or the name of a category. We call that nominal, and when it's nominal, you use a bar graph with it. So then question number D, favorite television show during the previous year. Favorite, almost is suggesting ordinal, but it's not asking for like a first, second, or third. It's just the one favorite. What's the most popular, or the one that you like the best? So that sounds to me like nominal. Let's see if that's right. Yes, it's nominal. Okay, and because it's nominal, right? Because we're just asking about like a name of a category, it's going to be a bar graph that you're going to use. Okay, so that's question number 11. Let's go ahead and move on to question number 13. And look at that. We got a question, looks like it's going to have a polygon in it. Okay, so what's the question asking? It's asking, find each of the following values for the distribution shown in the following polygon. Okay, so the authors of the book created a polygon for us. What they want us to do is use the polygon to create a frequency table, right? That column of X and F values. So I went ahead and did that, and this is what I got. I got that for the score of 5, there were 2 occurrences. Let's see if that's right. For a score of 5, yeah, there was 2 occurrences. For 4, there were 5 occurrences. For 3, there were 6 occurrences. And I know this kind of looks like for 3, there might have been 5 occurrences, but I kind of did a bad job of copying this picture. And notice how my x-axis is going kind of with a downward slope. So that's why it looks like it's a 5, but it should be a 6. But anyway, so I've created my frequency distribution table, my column of x values showing the different scores that people could have answered, and then my F column showing how often each score was said by someone. Okay, so with that, we've got 3 questions that we need to answer. First question is, what was the N? How many people were there in this sample? Remember that the way that we answer that question is we add up the numbers in your F column. And that gives you the total N in the study. Here I got it at 17. So what I'm going to write that is I'm going to say n equals 17. But then the next question that's being asked is to find the sum of x. Remember what we have to do here is we have to count up the total number of x's that we have. And the way that we do that is we create this x times f column. The reason why we're doing that is because we have to count out every time there was a specific x. So here we're saying we have 10 in this row because there were 2 5s. 5 plus 5 is 10. Here we got a 20 because there were 5 4s, and that ends up equaling 20. Got 18 because there were 6 3s, 6 because there were 3 2s, and a 1 here because there was only 1 1. But once we've created this column, we then can go and add it up, and that gives us a sum of x of 55. But then there's that last thing that we've got to do, that last calculation, sum of x squared. Remember that the first thing that we have to do here is now create that x squared column where we take each of our x values and we square them, right? So 25 because 5 times 5, 16 because 4 times 4, 3 times 3 is 9, 2 times 2 is 4, 1 times 1 is 1. But to sum these up, what we have to do is take that x squared column that we just created and multiply it by its corresponding f values. So we've got 25 times 2 is 50, 16 times 5 is 80, 9 times 6 is 54, 4 times 3 is 12, 1 times 1 is 1. Once we've done all that math, then we can add the values up, and we get an answer of the sum of x squared is 197. From there, we're moving on to number 15. And what we have here is a set of scores. And they're saying, first, construct a frequency distribution table. So that's this here, right? Got our answer for A. We've got all the x values that we see in our x column. And then in our f column, we have the number of times that each x value occurred. So that's our answer for A. From there, question B, sketch a histogram showing the distribution. And that's this answer here, right? So we created a histogram. You know it's a histogram because the bars are touching. Remember that on the x-axis, you have all the potential scores that you see in here. And on the y-axis, you have their frequencies. Okay, that means that we can go ahead and move on to question C. Now, in question C, they're just asking us to describe the distribution using the following characteristics. So I believe that they're specifically referring to this distribution. And the question they're asking is, what is the shape of the distribution first off, right? So remember, we have to draw that curve over it. And it almost looks like it's going to be a normal curve, except you've got a bunch of tall bars over here and a bunch of low bars over here. So when we end up drawing the curve, it ends up looking like that. And remember, that kind of curve has a name. It's either a positive skew or a negative skew. And I'm wondering if you remember what the logic is for why it would be positive or negative. Remember that the logic is it's going to be positive or negative based on the direction that the tail is pointing. What direction is the tail pointing? Is it pointing to the positive direction or is it pointing to the negative direction? In this case, it's pointing to the negative direction. So the shape of the distribution is, we refer to as a negative skew. Okay, so question number 2. What score best identifies the center or the average for the distribution? Normally when I look for the center of a distribution, I look for the tallest bar. Right, and the tallest bar generally represents the average, except not necessarily in this case. And the reason not in this case is because even though this is the tallest bar, you've only got a couple of bars to the right of it and a ton of bars to the left of it. So really what we might say then is that for question number 2, x equals 7 looks like where the average score is. Okay, so question number 3. Are the scores clustered together or are they spread out across the scale? The answer to that is they're clustered at the high end, right? Most of the scores are in this section here. That's a little cluster they got. Where is the cluster? The cluster is at the high end of the scale as opposed to the low end of the scale. Okay, from here, I have a bit of a nice surprise for you, class. We just answered question 15. I am going to skip 17, 19, and 21. I'm going to skip 3 questions for you. 3 questions for you. The reason why I'm going to skip those 3 questions, if you look at those 3 in the book, they all basically ask about the same topic. And you're looking at tables again. You have to work with what they call percentiles. And I'm skipping those questions because there is a lot of work that goes into answering those questions. Like maybe an hour's worth of work trying to explain what to do with those questions. But for all that work that you end up doing trying to answer all those questions, you never are going to use any of the information that you gain from answering those 3 questions. You're never going to use that information again in the book. So I'm going to skip over those questions since we're never going to use the information in this class. You're welcome. But from there, we'll go ahead and move on to the last 2 questions, question number 23 and 25. Here, question 23 is asking about something else that you learned about in chapter 2, that stem and leaf display. Basically what they're saying is construct a stem and leaf display for the data in problem 5 using one stem for the scores in the 50s, one for the scores in the 40s, and so on. All right, so basically what they're saying is go back to problem 5. That was this problem here where we had this data set. And they're saying take that data set and create a stem and leaf display with that data. So this is what I did. Remember, the stem and leaf is where you create the stem on one side of a line and the leaf on the other side of the line. Remember that the stem is the first digit of each number that you see, right? So for instance, that 1 there, that means that for some of these numbers, I must have had some digits where 1 was the first digit. So I got a 1 is the first digit there, a 1 is the first digit there, and a 1 is the first digit there. So, okay, so there, 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 and there. What was that? 1, 2, 3, 4, 5, 6. 6 different places where there were 1 was the first digit. So what we're going to do is we're going to say, okay, we're going to represent all of those numbers with that 1 in the stem. And then we're going to represent the rest of the numbers in the leaf, right? So you got a 9, a 7, an 8, a 3, a 6, and 8. What that's saying is you had one number that was a 19. Where was that 19? That 19 was right there. You've got another number that was a 17. Right there. An 8. So that must be that you've got an 18. There, 13, 16, and 18. Right? Remember that we said that we had 6 numbers that started with the 1. So what you should have then is 6 digits on this side as well. The 1 representing the fact that it's a teen, and then this this number over here that's representing exactly what place in the teens it was. Then you do the same thing with numbers that start with a 2, numbers that start with a 3, numbers that start with a 4, numbers that start with a 5. Just to make sure that you should understand this. So this is saying that there were 2 numbers in the 50s. One was a 51, and the other one was a 52. Let's see if that's right. Let's see if we find a 51. Okay, there's our 51, and there's our 52. Okay. So that's how you answer that question number 23. Moving on to question number 25, it's basically the same thing. Use a stem and leaf display to organize the following distribution of scores. Use 6 stems with each stem corresponding to a 10-point interval. So we had 6 stems, and then the 10-point intervals are in here, right? So same exact thing. I'm not going to explain it because I think that at this point you've got it. And this is the last question on the page, so I'm going to go ahead and call it a day. Thank you very much for your time, and I look forward to seeing you in Chapter 3.